Okay, it's just basically the same question as the first one. So we're looking for 60 meters squared is their area, and how are we going to place the stones to minimize the perimeter and maximize the area. So we're looking for some kind of rectangle, and we've got a length and a width, and we know that the area is length times width, so 60 should equal length times width, but I want one variable in terms of the other, so I'm going to divide both sides by length, and I'm going to end up with width is equal to 60 over length. Alright, or 60 over length equals width, and then I just reread it. So we've got some kind of thing there. And we also know the perimeter for this one is going to be 2 lengths plus 2 widths, because we want the length on the top and the bottom plus the width on the left and the right. And then we're going to grab our Excel spreadsheet again, and we're going to say, okay, the length, I don't know, let's vary it. Let's start with 1, and then go to 2, and then 3. I've got a pattern here, so I'm going to highlight this pattern. I'm going to grab the bottom corner and zoom it down until wherever I want to. The width we said is going to be equal to, so equals 60 divided by whatever the length is. Okay, and we can zoom that guy down as well. And the perimeter we know is going to be equal to 2 times whatever the length is plus 2 times whatever the width is, and the area is going to be equal to the length times whatever the width is. There we go. Now I can take this guy and zoom him down. And I can do the same for this guy, zoom him down. The area better be the same all the time. Okay. And we're going to watch the perimeter to get smaller and smaller until we get to a minimum. 32, 31. Oh, it looks like it goes back up to 32 again. So it looks like it's in this range here that we're going to have our minimum. So we can certainly decide, do we want to be cutting stones or not? And we could be getting into decimals as well. So it looks like the minimum is down in this 31, so 8 by 7.5 is 31. I'd be interested if what if I stuck an extra line in here, insert, and I could even go into smaller numbers and made it down, because we know it's somewhere between this one and this one, right? Or somewhere in this range here. So in fact, if we're closest to a square, we'll find our best value. So we could decide this is our best one. We're going to say I'll have to cut some of ours, or you could actually decide, go ahead and say 6 by 10 or 10 by 6, which is the same thing, just turned around. Gives us 32. It's close enough, but we don't have to cut squares. So you get a bit of an option of what you want to do. In fact, the closest it is to a square, the better. So if I put in here the square root of 60 equals square root, SQRT is the square root of 60. 60. Enter. That's a horrible looking number, but watch this. If I grab this guy and bring it down, it's going to be that same horrible number. This one's going to go to an even smaller minimum, and this is still going to be 60. So in fact, that's our best dimensions, but we're not really going to in practice cut to 7.74. But that's going to give us our smallest one. Look, it's just a little bit under 31. Not so much that it makes a difference though. So 7.5 by 8 is the best, but this is bang on for math. This is more likely what we're going to do for real life, or if we don't want to cut it, we're going to go to here. So we have a few different options.